What's up, everybody? Today's Friday, which means today we're going to be looking at an interesting topic in probability and statistics called Simpson's paradox. No, not like Homer Simpson. Simpson paradox is the paradox in which a certain trend in different groups of data disappears when those groups are combined. Let's make use of a fun example from basketball. LeBron James versus Michael Jordan. To provide some background, LeBron James has drawn comparisons to the great Michael Jordan as early as his junior year in high school. However, it was not until LeBron's recent success in the playoffs that a legitimate comparison could be made between the two All-Stars. Now, the comparison is difficult, though, because there's so many different factors to look at, like teammates, competition, defense, position, versatility. So let's just take a look at one of the biggest factors, scoring. Now, to make this comparison as fair as possible, we're just going to look at the statistics for their first 10th season, and the reason for that is LeBron has only played 10 full seasons to this point. We're also going to replace Jordan's 10th season with his 11th season, because his 10th season was the one where he came back from his first retirement, and he was pretty rusty. So let's start off by looking at two-point percentage. Jordan's percentage for two-pointers is 52.7%, while LeBron's is 52.8%. Pretty much the same, but numerically LeBron has an advantage. Now let's look at three-pointers. LeBron's shooting 33.7% from three-point land, and Jordan's shooting 32.7%, so LeBron does again have a slight edge here. Finally, though, let's look at field goal percentage. LeBron is shooting 49%, but Jordan is shooting 49.7%. LeBron shoots at a higher percentage in both twos and threes than Jordan. However, his overall field goal percentage is actually lower than Jordan's. Does this make sense? How can he be more accurate in each type of shot, but be less accurate overall? This is confusing to people at first because it doesn't seem very intuitive. However, Simpson's paradox is nothing more than a case of weighted averages. In our example, LeBron James shot higher from both two-point and three-point range. However, let's take a closer look at the data. LeBron James attempted 12,385 shots from two-point range and 3,026 shots from three-point range, which means about 20% of his shots have been three-pointers. Jordan, on the other hand, has attempted 16,282 shots from two-point range and 1,215 shots from three-point range, which means about 7% of his shots have been from three-pointers. So when we look at field goal percentage, which is a combination of the two data sets, we have to remember that we need to take into account the size of the data sets. LeBron's overall field goal percentage is brought down by the fact that he takes a significantly higher number of three-pointers compared to Jordan. This might make more sense if we look at a little bit of the math. In Jordan's case, we can calculate his field goal percentage by weighing his two-point percentage and three-point percentage. Take his shooting percentage for two-pointers, 51%, and multiply by the percentage of two-pointers he takes. Then add this to his shooting percentage for three-pointers, 32.7%, and multiply by the percentage of three-pointers he takes. Now do the exact same thing for LeBron. You can see that Jordan's 51% shooting is weighted much more heavily than his 32.7% shooting. Relative to Jordan, LeBron's 52.8 shooting percentage for two is weighted much less heavily. Finally, let's take a look at a vector representation of the data. Here, we're looking at makes versus attempts for the three types of shots for Jordan and LeBron. The slope indicates the shooting percentage, so as we can see, LeBron has a higher percentage for both two-pointers and three-pointers. But what's useful as a visual here is the magnitude or length of the vectors. Since Jordan's two-point vector is larger in magnitude than LeBron's, and his three-point vector is significantly smaller in magnitude than LeBron's, we see that Jordan's field goal vector ends up being more top-heavy, and therefore steeper in slope than LeBron's. So I guess for now we'll give the edge to Jordan. Thanks for watching.